This is part B of the Model Sim tutorial. In the first part, we had entered in the code for the full adder itself, and we had left it as such. The file has been saved. We can go ahead and re-minimize, unzoom, and the file's here. Let's just keep it here. Let's go ahead and create a new file. Now, what has happened here is that we see that the library window is here, and then if I can go and click on the project tab, you see the project tab there. My transcript is this way on mine, and then here is my source code window. Your layout may be different, and you can play with that as you wish. You can simply go to window here, and you can see which windows are indeed shown as such, and you can also go over here to view and then pick, the library window, the project window, the transcript, and so on and so forth, in case if you have accidentally closed those out. Alright, now we want to go ahead and add the test bench. So once again, go to your project tab, right click, add to project, a new file. What do we want to call this one? Well, there are many ways to go ahead and do this, right? If you use the word test bench, well, everything has a test bench, and it gets a little bit monotonous. So I'm going to use a really lengthy file for here, and I'm just going to call full adder underscore tb for test bench.bhdl. Once again, we're keeping the file at the top level. In a large design, that would not be the case. The files would be in different locations and as such. Okay, double click on your full adder TB, and it brings up the edit window as such. I can go back and redock it and zoom it back out. Let's go ahead and add the comment here. Project 1, full adder. Okay, there's the test bench. The test bench is just like any other modules. The only difference is that it really doesn't have any inputs and it doesn't have any outputs. It is usually the top level of your design for simulation as such. So once again, we'll start with entity, and we've chosen the word identifier full adder underscore TB. Alright, is, well, there are no input signals, there are no output signals, so it's end entity, and that is all you have there. We can then move on to what is the architecture. The architecture, once again, it's just an identifier. I'm using the word behave of test bench. Of full adder underscore TB. There's a change in the notes. I changed the identifier name there. Okay, is. Okay. We're going to have our begin and end behave. So what exactly, once again, is our test bench? Well, the test bench is going to take your module, instantiate it, and drive it with stimulus. So as such, you need to first of all tell it what is the module that you want to instantiate. What is the interface to it? Well, there are two ways to go about doing this, right? The simple way and the easy way is this. Let's go back to our full adder. Okay. Let's just simply go ahead and copy the entity declaration. So as I'm learning, again, I'm from the Linux side of the world, and the cut and paste characters are a little different. The select line in I guess Windows is you hold the shift and the up arrow, and you can go ahead and select what you want to. So I'll go ahead and do a Control C for a copy, right, and then go to my full adder test bench, go to where I need to, and then a Control V to go ahead and paste. Okay, this is a nice easy way to do it. It saves you a lot of typing, saves you from making mistakes. The only thing now you have to do is change the word entity to a component. Okay. What this means is when I make a reference to a full adder here in this architecture, this is the actual interface and this is the actual full adder that we're referring to. Okay? The interface of the full adder, that is. All right. Okay. Now, from our picture, we're going to connect up the full adder, but let's go ahead and just instantiate the full adder first. Okay, how do we do that? Well, you can have as many of these full adders as you want. You need to give a unique identifier, and it's called an instance. This is from old convention. Usually use a capital letter followed by a number. Okay, say like U0 or something like that, followed by a colon, and then the name of the component. In this case, is full adder. And now we're going to tell it how it is connected. It has a port map, and it's going to say what are the ports. I have port A, that is going to be connected to what? Well, I'll tell you in a second. Comma, and then port B is going to be connected to this. This is called explicit port mapping, and I like to do that because mistakes do get made. Okay. Sum, I'm going through each one of these ports. Carry out. Okay. All right. So what are they going to be connected to? Well, we need to define those signals. So let's go back up here. All right. Signal. Well, let's do the inputs first. Now, it can be the exact same name as the port. That's not an issue. I'm going to call it a different name in this example here, just for clarity's sake. So let me just call it A underscore TB, B underscore TB, where the TB obviously refers to test bench, C underscore TB, and what are they? They are bits. Okay, so I've declared three signals: ATB, BTB, and CNTB, and they're all bits. And we need the outputs also. I can put them on the same line if I wanted to, but it's just nicer. Sum, carry out, and it's a bit. Okay? Okay, now let's go and connect them. So A is connected to A underscore TB. Note that the arrow is opposite to what the assignment operator is. B underscore TB. CN underscore TB. Sum, probably should have been here. Sum, let's go on, excuse me, sum underscore TB and carry underscore TB underscore TB and carry out underscore TB. Okay, so now we've instantiated our full adder. We've connected it. What we haven't done is we haven't provided any stimulus or values for these three inputs. Now, in general, well, what do we essentially want to do for a full adder? We just want to walk it through the input combinations that were present in the truth table. Okay, so let's go and do that. Now, how do you do that? Okay, so what you're doing is creating a sequence of actions, right? You want to go through one set of inputs, apply them to the design, wait some time, see what the result is, and then apply the next set of inputs. Thus, you're creating a process. Okay? So, process, begin, end process, semicolon. So what are we going to do here? Okay? Well, first let's just walk through the table, right? The table says we want carry in to be 0, A to be 0, and B to be 0. Okay, so let's do that. So carry in, we'll set it equal to, and this is really important here. What do you call this thing? Single quotation. We'll set it to 0. Okay. Then go ahead and set A. Set that. Excuse me, mistake. carry in test bench equal to 0. A underscore test bench, set that equal to 0. And B underscore test bench, set that equal to 0. Okay? I just put it on the same line just for clarity's sake. Now what do we want to do? We want to wait for a little bit of time. Well, the syntax for that is simple. Wait, okay, for a number, so let's say 10, space, and then how many units, what the units are, nanoseconds. All right? That looks good, all right? And then we're going to walk through the table, so why don't we just simply cut and paste these two lines and modify them, right? Control C. So we have a total of 8 combinations. We've done 1, 2, 3, 4, oops, 4, 5, 6, 7, 8. A little bit of a lag here. Okay, so let's walk through the combinations. We want all 0, 0, 0. Then what? Then 0, 0, 1. And then 0, 1, 0. Then 0, 1, 1. And then 1, 0, 0. 1, 0, 1. 1, 1, 0. 1, 1, 1. Okay, so we walked through all the combinations for the inputs, right? So what happens when we get to here? Well, the process will repeat itself again and again. So why don't we just do this here, just so that we can see what's going to happen. So we'll just put down, let's say, wait for, gosh, 200 nanoseconds or something like that. Okay, are we done? Well, let's just take a quick look. Yeah, it looks like we pretty much got everything done here. All right, let's go ahead and save the file. Okay, it's saved. Let's go back and unzoom. All right, so we've created the full adder VHDL, the full adder test bench VHDL. I'll stop at this point and pick up from on the next one on compiling and simulating.